Okay, we're back. We're on Sequences and Series Introduction. This is Mr. Morrissey, and we are on example 4. It says, consider the sequence -9, -5, -1, 3, 7, ... in which each term is 4 larger than the previous term. Find a formula for the nth term of the sequence. Basically, this is the same thing as saying, find the rule. Well, let's see. If we consider the first term, a sub 1, that's -9. The next term, a sub 2, is just going to be a sub 1 plus a difference, which we're going to get into in the next lesson. But the difference here is 4. So you're adding 4 each time. A sub 3 would be the first value plus 2 of the differences. So if we wanted to find an equation or a rule for the nth term, it seems like this would be the nth term. So this is going to represent, so a sub n equals nth term. You notice on the second term, you're only adding 1 difference. And on the third term, you're only adding 2 differences. So the nth term is going to equal the first term plus some amount of difference. But like, for example, this third term, you only add 2 differences. This second term, you only add 1 difference. So it's going to be n minus 1 times difference. Let's check to make sure that actually works. And this will be the basis for the next, for tomorrow's lecture. So let's check here, the 1, 2, 3, fourth term. So we're wondering, the fourth term, does that equal the first term plus 4 minus 1 times the difference, which is 4. So -9 plus 3 times 4. That equals 3. And 3 was what we were just trying to test. So the nth term, or sorry, the formula for the nth term is a sub n, which is the nth term, a sub 1, which I know it says this in the notes, but I'm just going to make sure you realize this. This is the first term, and d is the difference. In this case, d is 4. All right, cool. We got one more to do. We're almost done. Okay, we had 2 problems here. Sigma notation. Expand this term and this term. So let's split it in half here. So the first one, n is 0. So wherever we see an n, we're going to put a 0, then a 1, then a 2, then a 3. And since this is infinity, it goes on forever. So for the first one, we do x to the 0. Since it's sigma notation, we're going to keep adding successive terms. So x to the first, x to the second, plus ... Done. Oh, actually, no, we're not done. We probably should make this x to the first. Okay. All we're doing is expanding here. All right. So, now, the next one is the same process. K is 1. We're going to plug in K1, then we're going to plug in 2 and 3 and 4 and 5. And we're going to also try to look for a pattern. So let's see. The first term plus K is 2. God, I hope I'm not getting the sniffles like the first set of videos. Let's see. Plus, let's do one more. No, 2 more actually. Let's do 2 more. Let's see. So we just did 3. Now we're doing 4. All right. Let's see. 2 minus 1, 1. Plus 4 minus 1, 3. Plus, looks like we're having odd integers here. 6, 5, 7. Let's find the last term. So plus ... plus plug in for 8. So let's plug in 8 up here, guys. So 2 times 8 minus 1. So that's 15. So this is our answer. It just says expand. So just remember, when you see the sigma notation means you're summing up the values. So we're summing up, plugging 1, which is the k value, in here for k, figuring out what the answer is, which is right here. Then plug in 2, then plug in 3, then plug in 4. Now I did a dot, 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 and I plugged in the last term. And it's not telling you, it's not asking us to actually find the sum. We'll do that in a future lesson. All right? Great job. And we are going to summarize. And please tell me what you think the key skills are that we practiced today in our Sequences and Series Introduction. And write down one question that you have. All right?
Found a girl and you married